Today's video is on unpredictability. Now, what does this have to do with quantum particles? Well, don't worry, we'll go over it a lot this entire series. But basically, the sheer nature of quantum particles and the quantum realm is extremely unpredictable and uncontrollable. So many aspects can't be foreseen. And the key idea for today is even the act of observing or viewing some scenarios can change the outcome. Let's try and imagine this with an example.
Here, I have a Rubik's Cube. It's all mixed up, as you can tell. Pretend this cube is something we, as the scientists in this scenario, are trying to observe. To make this example relate, let's imagine we try to solve it blindfolded. To make matters worse, we can't even see the starting position. We can only assume things about the cube. We can assume, based on the probability of the positions of the pieces, where they might actually be. For instance, since there are 12 edge pieces, each with 2 possible ways of orientation, we can assume any outcome of the position of an edge piece with a 1/24 or 4.16% probability chance. The corners, of which there are 8, with 3 possible orientations each, also leave us with a 1/24th chance that our assumptions are right. This is reflected well when looking at actual quantum particles, in which the state, without observation, can only be calculated by a chance or probability. So let's go back to the cube. We can assume that we may have to turn a side up to get us closer to the end product, or we can assume that we would have to turn the top or the front, for example. We can only make these assumptions about the data and are uncertain if they hold true. This whole time, we can turn the cube a million different ways, never knowing if we actually reach the end goal. Here's where the fun comes in. We look at the cube finally, hoping to see if we reach the solved state. But our observation actually does something to the cube. It changes the state of the cube, basically resetting our assumptions, and it prevents us from ever knowing if we reach the ideal end result.
We never know if our assumptions hold true. Now, let's go to the whiteboard and analyze this another way.
This can also be seen and related to in a mythological story, the Greek myth of Orpheus and Eurydice. Orpheus loses Eurydice to a snake bite and seeks to bring her back from the underworld. He is allowed to take her back on one condition. He can't look back to her as they walk out of the underworld. Orpheus, feeling doubt that the promise was true, looked back not long before they would have crossed back out of the underworld. He didn't see her there, because he had broken the conditions of the deal. His mere observation had prevented him from seeing the true state of the promise, whether she was actually behind him or not.
When we, as scientists, try to collect and record observations for data, we can actually change some aspects about these quantum particles. Quantum law is dictated by probability, not by certainty. So as we delve deeper into this world full of mystery, we approach a realm of true unpredictability. Thanks guys for watching. If you have any questions, leave it down in the comments below. As always, I will leave my links to the Twitter and my blog in the description. Hope to see you guys next time. Bye-bye.